problems. So find the unique number of permutations for the letters in each word. There's no repeated letters in the word wrapping, so this is just 7 factorial, which 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1 is 5,040. Now there are some repeated letters here. There's 2 O's and there's 3 R's. So it would be 6 factorial, except for we got to get rid of those repeats by doing a 2 factorial times a 3 factorial on the bottom. So this is going to significantly reduce the number of combinations because they're not really unique combinations. And we get only 60 recombinations here with only one less letter because of the repeated letters and this word unique up here. All right. State if the scenario involves a permutation or combination, then find the number of possibilities. A team of 13 field hockey players needs to choose 2 players to refill the water cooler. So this is a combination because order doesn't matter. It doesn't matter who goes first and who goes second. We just go 13, choose 2, and that is 13, choose 2, 78 different combinations we can send. Now in 56, we got to choose a president and a vice president. So there the order does matter. It's different if we pick Billy for president and Joe for vice president versus other way around. So we want to do 65 P2. We'll see we get a much bigger number with permutations because of all those extra combinations that work. That are just rearrangements. So 4,160. Determine whether it's independent or dependent events, then find the probability. So a spinner has equal chance of landing on each of the 5 numbered regions. You spin twice. So will spin 1 affect spin 2? Well, not if it's a good spinner, so this is independent. And then what's the probability the first spin lands in region 1? So that's a 1/5 probability. And the second spin lands in region 1. That's another 1/5 probability. We multiply them together to get that it's a 1 in 25 chance of that happening. All right, there's 5 nickels and 5 dimes in your pocket. You randomly pick a coin out of your pocket and place it on the counter. Then you pick another one. So the first one you draw out will affect the second one. So this is dependent. Missed my N in there. What's the probability that both coins are nickels? So the probability that the first coin was a nickel was a 5 out of 10. But the probability that the second one is a nickel is a 4 out of 9 because there's 9 coins remaining, but only 4 of them are nickels for a total of 20/90ths or 2/9 chance. All right. A test consists of 7 true-false questions. A student forgets to study. What's the probability the student answers exactly 3 questions correctly? So there's 7, let me write this different. 7 choose 3 ways to pick those questions. A 50% chance of getting it right to the power of 3. So that's for the ones you get right. And then 50% chance of getting it wrong to the power of 4 for the 4 questions you got wrong. Multiply this all together, we get 7, choose 3, times 0.5 to the third times 0.5 to the fourth is 0.27, which equals 27% chance that you get exactly 3 questions correct. All right. 6-sided die is rolled 6 times. What's the probability the die will show an even number exactly 4 times? So it's rolled 6 times. So 6 choose 4 to figure out the number of times it shows, or the number of ways to combine those 4 wins. The probability that it's even is a 1/2 to the power of 4. And then for the other 2 rolls, for them to be odd is also 1/2 to the power of 2. So 6 choose 4. And I'm getting a 23.4% chance on this one. All right, to determine if 2 events are independent, you multiply them. Let's see, these do not multiply to equal that, so these are not independent. Doesn't mean that they're necessarily dependent, but they're certainly not independent. I guess if you're not independent, then you are by default dependent, but there's different types of dependence, I guess, is what I'm trying to say. Let's see if I multiply these. This does work out, so these are independent. All right, to figure out if two events are mutually exclusive, you add them and see if they add up. These ones do add up, so they are, yes, mutually exclusive. These ones over here do not add up, so they're not mutually exclusive. All right, and let's call that good for that. No more problems on here. Go back and review other things to make sure you are fully